Dividing complex numbers. Division can be overwhelming, especially when you talk about fractions, but just know that you can do this. When I look at this, I see so much going on that I have to break it apart and makes it easier to flow better. So if I was to look at this here, I got this numerator divided by this denominator, and this whole side here is also considered as a numerator because it's all divided by this other part over here, which again, you have a numerator divided by a denominator. And then we got proper fractions divided by mixed numbers. So we got a lot going on. So let's just clean this up and let's do one thing at a time. And just know that you can do this. So what I'm going to do is I'm going to rewrite this. I'm going to take this first one and I'm going to write it in a format that I can see it better. Now again, I am going to do it in one part at a time. So I'm going to do this part first. Okay? So you can label it how you want. But I'm going to do, like I said, I want to separate it. I want to do it in parts. So I'm going to change the color of my pen just a little bit. And I want to talk to you about dividing with fractions. There's a rule when dividing with fractions, and that is you keep the first term, comma, change the operation, and then you flip the last term. So let's look at that. What do I mean? I mean, we're going to keep this one. We're going to change this to multiplication. Multiply. And we're going to flip this one. Keep, change, flip. And I just want to clean up my writing here so it's a little more easier to read. We're going to keep, change, flip. So let's do that. We got 3/5. We're going to change division to multiplication. We're going to flip the second. Now remember, this rule applies to dividing with fractions. So this could have been a whole number, or this one a whole number, and this one's a fraction. All that matters is that we got a fraction being divided by something. Then we can apply this rule, keep, change, flip. So once I do that, I got it in multiplication form, and I ask myself, is there a number on top that will reduce with the number on bottom? And I do see a number on top that will reduce with the number on bottom. 3 goes in 3 one time. So therefore, that becomes a 1, and that becomes a 1. Now I got 1 times 4, which is 4, divided by 5 times 1, which is 5. So now I have my first term taken care of. So I'm going to come over here and put 4/5. And it's all going to be divided by this other side. And this other side, guys, we need to work out over here. So I'm going to scroll down just a little bit and give myself this side of the page so that way I don't run it into the other. So let's do that. Let's take our numerator over there, which is 4 divided by 5, which, wow, kind of worked out. But anyways, we're working over here in the green, so I just want to, let's make this where you can see it. We're going to work over here in the green. Okay. So I got 4/5 divided by 1/9. What I want to do is, yeah, there's more than one way, but I want to clean this up. This is a mixed number. Let's convert this to an improper fraction. And when I do that, guys, there's a rule that you follow. You go, okay, the denominator does not change, okay? And then we say 9 times 1 is 1. right? Times 9. I said that wrong. Did y'all catch me on that? I said 1 times 9, 9 times 1 should be 9. And then I'm going to add it. 9 plus 1 gives me 10. So my new numerator is 10. So to convert a mixed number to an improper fraction, we keep the denominator the same, and we take this denominator, multiply it to the whole number, and then whatever that answer is, you add it to whatever that numerator is, and it yields out a new numerator that we're going to be working with. So let's go ahead and bring this down. So now I got it written like this. I can apply the rules of keep, change, flip. So let's do that. Let's keep our first the same. Change division to multiplication. Flip the other one. Well, now that I've done that, I ask myself, is there a number on top that will reduce with a number on bottom? And in this case here, we got 4s, which is 2s, 9s, which is 3s, 5 is prime, and 10 is 2 and 5s. So no, there's not a number on top that will reduce with a number on bottom. So what we're going to have to do is go ahead and just multiply them straight across. So 4 times 9 is 36, 5 times 10 is 50, and we're going to come over here and we're going to write 36 over 50. So here is our new, now it's all cleaned up, guys. Looky here. We got it cleaned up. This here is this down here. Just all cleaned up, guys. So yay. So we're going to apply the rules. We're going to keep, we're going to change, and we're going to flip. So now, keep the first the same, change to multiplication, flip it, and then flip the next one. And now we can ask ourselves, we can say, is there a number up here on top in the numerator that will reduce with a number on bottom? Well, yeah, it worked out great that 4 goes into 36, right? And 5 goes into 50. So what do we get here? We get, let's change the color. 4 goes into itself once and goes into 36 9 times. 5 goes into itself once and go into 50 10 times. And now we multiply across. 1 times 10 is 10. 1 times 9 is 9. And wow, what do we have? We have a improper fraction. So we have 10 ninths, and this is called an improper. Improper means that the number in the numerator, the number on top, is larger than the number on bottom. If the number on top was smaller than the number on bottom, then that means it would have been proper. But in this case, we have improper. The numerator is larger than the denominator. That means we can convert this back to a mixed number. And let's do that just in case you come across a problem, you have to do that too. So again, rule, whenever we're working in this conversion part of improper fraction to mixed, mixed to improper fraction, the denominator does not change. So I'm going to go ahead and come over here and put the denominator down. And I ask myself, well, I need to figure out what rule applies in order to get 10, right, as my numerator. So whatever rule I got to apply, we know that 9 times some number here then added would give me back that 10. So let's ask ourselves, 9 times what will get close to 10? Well, 9 only goes into 10 once. So that one was pretty easy. The 9 times 1 is 9. 10 minus 9 is 1. So that is my new numerator. So just repeat myself. The denominator stays the same. 9 times 1 is 9 plus 1 is 10. Boom, we got our improper, and vice versa.